History is often written by the victors, but in the world of science, it is sometimes written by the loudest voices. We are taught to believe that the discovery of black holes is a modern triumph, a jewel in the crown of late 20th century physics, polished by the likes of Stephen Hawking and Roger Penrose. We assume that humanity simply hadn't done the math until the computer age, but this is a lie. The math was solved in 1930 on the swaying deck of a steamship crossing the Mediterranean by a 19-year-old boy who held the secrets of the universe in a trembling hand. His name was Subrahmanyan Chandrasekhar, known simply as Chandra, and he had looked into the abyss long before the world was ready to admit it existed. The year is 1930. The steamship Pilsner cuts through the dark waters of the Arabian Sea, bound for England. On board are politicians, wealthy tourists, and colonial officials, clinking glasses and discussing the affairs of the British Empire. But tucked away from the festivities, sitting alone on a deck chair under the vast, uncaring canopy of stars, is a teenager from Madras. He is leaving his home, his family, and everything he knows to study at Cambridge, the Mecca of physics. He is armed with nothing but a government scholarship, a brilliant mind, and a notebook that would soon contain the death warrant of the classical universe. While his fellow passengers worried about seasickness or social standing, Chandra was wrestling with a problem that had stumped the greatest minds of Europe. He was thinking about white dwarfs, the dense, glowing embers of dead stars. The prevailing wisdom, championed by the titans of astronomy, was that all stars would eventually settle down into a peaceful, stable retirement. They would shrink, cool, and exist quietly forever. It was a comforting, orderly thought. But Chandra, with the fearlessness of youth, decided to apply the new, strange rules of quantum mechanics and special relativity to these stellar corpses. As the Pilsner sailed closer to Europe, Chandra's calculations began to reveal a terrifying anomaly. He found that there was a limit. If a dying star had a mass greater than 1.44 times that of our Sun, a figure now immortalized as the Chandrasekhar limit, it could not settle down. The electron pressure that was supposed to support it would fail. Gravity, relentless and infinite, would win. The star would not stop shrinking. It would collapse past the point of matter, past the point of logic, crushing itself into a singular point of infinite density. It would vanish from the observable universe, leaving behind a rip in the fabric of space-time. Chandra stared at the equations. They were flawless. He had mathematically proven that the universe contained trapdoors from which nothing, not even light, could escape. He wasn't just doing homework, he was discovering the black hole, decades before the term would even be coined. When the ship finally docked in Southampton, Chandra stepped onto British soil with a heart pounding, not just from the cold, but from the weight of his notebook. He believed he was bringing a gift to Cambridge. He believed that the great men of science, men like Sir Arthur Eddington, would embrace this revelation. He had no idea that he was walking into a trap, and that the very discovery that should have made him a legend would instead turn him into a pariah.
The tragedy of Chandrasekhar is not that he was ignored, but that he was systematically dismantled by the one man he trusted most. By 1935, Chandra had spent 4 years at Cambridge, honing his theory. He had built a relationship with Sir Arthur Eddington, the most famous astronomer in the world. Eddington was a giant, the man who had famously confirmed Einstein's theory of relativity during a solar eclipse. To Chandra, Eddington was a mentor, a father figure, and the gatekeeper of the stars. Eddington visited Chandra's chambers, checked his math, and seemingly encouraged him. When the Royal Astronomical Society invited Chandra to present his findings in London on January 11, 1935, he believed his moment had finally arrived. The scene inside Burlington House was intimidating. The room was filled with the elite of British science, rows of stiff collars and gray beards. Chandra, standing at the podium, was barely 24 years old. He presented his paper with the precise, methodical cadence of a man who knows he is right. He walked them through the math of electron degeneracy pressure and the inevitable collapse of massive stars. He concluded that for stars above the critical mass, one is left speculating on other possibilities, a polite way of saying the star collapses to nothingness. He sat down, expecting debate, perhaps some skeptical questions, but ultimately acceptance. Then Sir Arthur Eddington stood up. Eddington had requested to speak immediately after Chandra. The young physicist thought his mentor would offer a supporting speech, a seal of approval that would secure his future. Instead, Eddington turned to the audience, ripped up the script of scientific decorum, and launched a brutal, personal attack. He didn't attack the math. He couldn't, because the math was perfect. Instead, he attacked the idea. He mocked the very concept of a star collapsing indefinitely. The star has to go on radiating and contracting until, I suppose, it gets down to a few kilometers radius when gravity becomes strong enough to hold in the radiation and the star can at last find peace, Eddington sneered, his voice dripping with sarcasm. The room began to chuckle. Emboldened, Eddington delivered the killing blow. I think there should be a law of nature to prevent a star from behaving in this absurd way. The laughter that erupted in that hall was the sound of a career shattering. It was stellar buffoonery, Eddington declared, reducing Chandra's elegant proof to a joke. It was an ambush. Eddington had known about Chandra's work for months. He had ample time to discuss it privately. Instead, he chose to humiliate him publicly. Why? Because the truth scared him. Eddington was a man of the old order, a man who believed in a harmonious, stable universe. The idea of a black hole, a region of total destruction, was philosophically repulsive to him. He used his immense authority to crush the truth simply because he didn't like it. As Chandra sat there, humiliated and burning with shame, he watched the scientific community side with the celebrity over the evidence. In that hour, physics stopped being a search for truth and became a contest of egos. The impact of that winter evening in London rippled through time, delaying the progress of astrophysics for nearly half a century. Following the humiliation at the Royal Society, Chandrasekhar found himself isolated. The great Niels Bohr approached him privately, whispering that his physics was correct, but refused to say so in public, fearful of crossing Eddington. It was a conspiracy of silence. Realizing that he could not win against the Pope of Astronomy, Chandra made a heartbreaking decision. He folded his notes on black holes, packed away the theory that should have been his magnum opus, and left England. He fled to the United States, effectively exiling himself from the field he had revolutionized. For decades, the Chandrasekhar limit was treated as a mathematical curiosity, a quirk with no basis in reality. Textbooks ignored it. Chandra reinvented himself, moving on to study fluid dynamics and other areas of physics, producing brilliant work but always stepping away before he could be hurt again. Meanwhile, the universe continued to behave exactly as he had predicted, waiting for humanity to catch up. It wasn't until the late 1960s and 70s, with the advent of radio astronomy and computer modeling, that scientists began to observe phenomena that could only be explained by total gravitational collapse. New names emerged: Stephen Hawking, Roger Penrose, John Wheeler, men who built their careers on the foundation Chandra had laid 40 years earlier. The vindication, when it finally came, was absolute but agonizingly slow. The scientific community had to awkwardly admit that the absurd behavior Eddington had mocked was actually the fundamental reality of the cosmos. The black holes that dominate our understanding of the universe today, the engines of galaxies, the keys to time and space, were the very things a teenager had seen on a boat in 1930.
The establishment had wasted 50 years protecting a comfortable lie rather than facing a difficult truth. In 1983, 53 years after his journey on the Pilsner, Subrahmanyan Chandrasekhar was called to Stockholm. He was an old man now, his hair white, his demeanor quiet and dignified. He was awarded the Nobel Prize in Physics for theoretical studies of the physical processes of importance to the structure and evolution of the stars. It was the highest honor on Earth, yet it was awarded for work he had completed before he was legally old enough to drink in some countries. As he accepted the prize, standing in the glare of the lights, one couldn't help but wonder if he was thinking of Eddington. The man who had tried to destroy him was long dead, his objections relegated to the dustbin of history. But the victory was bittersweet. How much further could we have gone? How many mysteries could Chandra have solved if his spirit hadn't been broken by a mentor's arrogance? His story is a permanent reminder that authority is not truth, and that sometimes the most profound discoveries are carried in the notebooks of the quiet, the young, and the ignored, waiting for the world to stop laughing and start listening.